So here in this question, we have two objects. Let me draw this. We have a slope like this, and we have a ball, let's say, let this be a spherical ball which is sliding down the plane. Let's call this point, this one O, this point A, this point, let's say, B. This ball is sliding down the plane AB, and it will ultimately reach the point B. At the same time, we have a projectile which is projected from the point O, and it takes the path, parabolic path like this, and reached the point B. We have some projectile which is projected with an initial velocity v, making an angle theta with the horizontal, and it will reach it is projected from the point O, and it reached the point B. Suppose the slope of this angle B, slope of this plane B, alpha. So in this question we are given the velocity attained by this ball at the point B and the velocity at which the projectile reaches the point B are the same. Also, this ball and the projectile reaches the point B at the same time. And we have to show, if that is the case, we have to show this relation. We have cos alpha equal to 2 cos theta and 2 sin theta equal to 1 divided by sin alpha. So, how will we do this? For that, let's first consider the motion of the ball along this plane AB. Let's write, consider the motion of the ball along the plane AB. See, the body is starting from rest. That is, initial velocity of the ball is 0. And we can use the kinematic equation V equal to V0 plus AT. This is the first kinematic equation of motion. So here we have an unknown acceleration. We need to find the acceleration along the plane AB. For that, let us resolve the acceleration due to gravity acting on this ball. That is, we have an acceleration, that is the acceleration due to gravity in the vertically downward direction. This gravity can be resolved, one along this plane and one perpendicular to the plane. Clear? We can call this as G dash. We don't need the perpendicular component of gravity. We are only interested in the acceleration along the plane. Let me draw this again here. Suppose this is our ball. We can resolve that as G in the vertically downward direction, and G dash, this is the velocity along the horizontal direction. Clear? Horizontal direction means not in the horizontal direction, acceleration along this plane AB. This is the point AB. Clear? And if you look at the angle, that is this angle, you know this angle is 90. Clear? This is right angle. So this angle will be, see, this is 90. So if you add these two, you will find that it also is 90, because 90 plus 90 become 180. So this angle will be 90 minus alpha. Clear? So this angle is 90 minus alpha. We are just using the angle sum property. So that we have G dash here. G dash will be G times, when you take this as the angle, G dash will be cos of this angle 90 minus theta. Suppose we have a vector, let's say this be a vector A, and if this angle is theta, then the component of A along the angle will be A cos theta. Clear? I just used that principle here. This 90 minus alpha is our angle, so the component along that angle will be cos of 90 minus alpha. Clear? So here it will be cos 90 minus, sorry, not theta, 90 minus alpha. Clear? So that G dash will be G into, cos 90 minus alpha is sin alpha. Call that as equation number 1. So this is our acceleration A. We only have one acceleration A, which is G dash, that is the acceleration along the plane, which is equal to G sin alpha. Now let us substitute this value in here. So V is equal to, initial velocity is 0, acceleration is G sin alpha times t. So this is equal to V equal to G sin alpha times t. Call that as equation number 1. Clear? Now consider, this is the motion of the ball along the plane. Now consider the motion of projectile. Motion of projectile from O to B. O to B. See, this O to B is the complete motion of this projectile. So the time it took from the point O to reach the point B will be the time of flight of the projectile. And we know the expression for time of flight, t is equal to 2 times the velocity of projection v times the sine of angle of projection by g. This is the expression for time of flight of the projectile. If you have any doubt regarding the time of flight, you can always go back and check the video. I already put the video of the derivation of time of flight. So this is the expression for time of flight of the projectile, because the time of flight means time taken by the projectile to reach the point B or reach to the point same level from the point of projection. So here you can take this g to the left. So gt is equal to 2v sine theta, implies we have v is equal to, you can take this 2 and sine theta to the left. We have v equal to gt by 2 sine theta. Call this as equation number 2. Now if you compare the equation 1 and 2, they both represents the velocity. You know the velocity at both the points, the velocity of the projectile and the velocity of the ball at the point B remains the same. It is given in the question. So we know equation 1 equal to 2, which implies g sine alpha times t is equal to gt by 2 sine theta. Clear? You can cancel this g and g. Also this t will get cancelled. So we have the expression sine alpha equal to 1 by 2 sine theta. Clear? Or you can write, if you take the reciprocal on both the sides, we have taking the reciprocal here 1 by sine alpha is equal to, if you take the reciprocal, it will be 2 sine theta. Which means this is our second derivation. We have 2 sine theta equal to 1 by sine alpha. Clear? Okay. Now we need to derive the second equation. That equation in terms of cosine. Let me write this again. Let me note these two values, or you can note this one. We have 1 by sine alpha equal to 2 sine theta. Now we need to derive the first equation. Again, consider the motion of the ball along the plane. Consider the motion of the ball along the plane. We know we can this time use the third kinematic equation, v square is equal to v0 square plus 2as, where v is the final velocity, that is the velocity at the point B, v0 definitely the initial velocity, a is the acceleration, this we know g dash is equal to g sine alpha, and s is the length AB or the displacement along the plane. So this can be written as v square is equal to v0 is 0 plus 2 into, instead of a you can write g sine alpha into s. Now if you take the plane, if you take this this plane AOB, this is our angle alpha. We know cos alpha will be this is the displacement s. This length is the displacement s. So cos alpha will be OB by this AB. Cos alpha, adjacent side by hypotenuse. So cos alpha is equal to OB. See, if you take the length OB, that actually means OB is the, for this triangle it is the base, and for the projectile it is the range. We call the horizontal distance covered by the projectile as range. So you can take OB as range of the projectile R divided by AB is S, which implies S is equal to, taking this cos alpha to the right, S equal to R by cos alpha. Clear? We can plug in the value of S in here. So V square is equal to 2g sine alpha into R divided by cos alpha. Let's call this as equation number 1. Now, let me erase this. Now we know the range of the projectile, or let's consider the projectile motion. Consider the projectile motion. We know OB, the range of the projectile, are equal to v square, that is the square of the velocity of projection, times sine 2 theta, that is 2 times the angle of projection, by g. This is also this is the expression of the range of the projectile. We derived this equation also. If you have any doubt, you can go back and check the video. So this is the expression for range of the projectile. So isolating v, you can take this g to the right. So rg equal to v square sine 2 theta, or you can write v square is equal to r into g by sine 2 theta. Call this as equation number 2. Now if you again compare the equation 1 and 2, that is, they both are v square. So equation 1 is equal to equation 2, implies you can write 2g sin alpha r by cos alpha is equal to rg by sine 2 theta. Clear? So you can cancel this g and this r. Simplifying, you will get 2 sin alpha into 1 by cos alpha is equal to 1 by sin theta, sin 2 theta, you can write 2 sin theta into cos theta, because you know sin 2 theta is 2 sin theta into cos theta. This is a trigonometric identity. So this is equal to 2 sin alpha into 1 by cos alpha is equal to, you can write this one as 1 by 2 sin theta into 1 by cos theta. 1 and 1 is 1 into 1 is 1. So you can multiply this denominator and it will turn like this. Now we have 1 by 2 sin theta. If you know 1 by sin alpha is equal to 2 sin theta, or if you take the reciprocal on both sides, this will become sin alpha equal to 1 by 2 sin theta. Clear? So 1 by 2 sin theta, that is, if you take the reciprocal on both sides, we already derived this equation, sin alpha equal to 1 by 2 sin theta. I just wrote this in here. So if you take the reciprocal on both sides, you will get sin alpha equal to 1 by sin 2 theta. This is equal to 2 sin alpha into 1 by cos alpha. Here you can write 1 by 2 sin alpha instead of 1 by 2 sin theta. Sin alpha into 1 by cos theta. Clear? You can cancel this sin alpha and sin alpha. So finally you have 2 by cos alpha equal to 1 by cos theta. You can take this cos theta to the left and this cos alpha to the right. So the final expression will be two cos theta equal to cos alpha. Clear? So that's our first expression. Clear?